Okay, our next example, which I believe is going to be example 4 or 5, I can't remember, whichever one it is. I'm going to look at two of them side by side so that we can discuss some things about this. I want to look at the limit as x approaches 1 of 2x plus 7 raised to the 3 halves versus the limit as x approaches 2 of 2x plus 7 to the 3 halves. And let's see how these are the same and how they differ. I'm going to start with the one over here on the left. And again, since I'm doing this analytically, I'm going to go ahead and just put in the value. Everywhere there's an x, I'm going to make it a 1. So this is going to become 2 times 1 plus 7 raised to the 3 halves. And that's going to give me, what, 9 raised to the 3 halves. Now, for those of you who depend quite often on your calculator, this is actually an answer that your calculators can spit back to you because it comes out nice and even. The answer to this is 27. But the answers aren't always so nice. So I'm going to come in here and show you how to work this, and then we'll do the other side, and you'll see that you're going to need to know how to do this as you work through these problems. If your answer is just x raised to the 3 halves, you are done. That answer does not need to be cleaned up anymore. But if we have a number raised to a power, we need to clean it up. It would be no different than, say, having x squared versus 3 squared. You would never leave a 3 squared as an answer. You would give me 9, but you could leave me an x squared. So here I have a number raised to a power. Remember when we were doing the fractional exponents, we said keep up with the radical, and it tells you what that thing is going to look like. So as a matter of fact, we can see that this is going to become the square root of 9 raised to the 3rd power. And there are several ways you can deal with it from here. I'm going to kind of take it out the slow way, just so you can see how this works. This tends to work all the time. If you can get to an answer from here, that's fine, but I'm going to show you what I do. 9 cubed is going to be the same as 9 times 9 times 9. And because I have a square root, anytime I have two of the same thing, I get to take one out. So I get to take out a single 9, leaving the square root of 9 still in the radical. But of course, I know the square root of 9, and if I need to, I can break it down. The square root of 9 is 3, but if you need to, go ahead and break down that 9 into 3 times 3. 2 of the same thing allows you to take one out, so you get 9 times 3, which is 27. Now that works out nicely again for this particular example because this would have come out in a calculator. However, let's look at the other side of this and see what happens here. This time I'm going to look at the same function, but I'm going to look at the limit as x approaches 2. So that means that everywhere there is an x, I'm going to make it a 2. I get 2 times 2 plus 7 raised to the 3 halves. Remember, you need a single value before you can raise it to a power. So that's going to give me 11 to the 3 halves. Folks, you cannot leave this answer. Remember, it's no different than trying to leave me 3 squared. I will not take that as an answer. And if you plug this into a calculator, it is not going to give you anything but a decimal, and decimals are not going to be acceptable. I need to know what this looks like. Whatever has to stay in the radical is going to stay in the radical, but whatever can come out needs to come out. Okay, so just like before, remember, keep up with what the radical is. And so we're going to rewrite this as the square root of 11 cubed. That's going to be equivalent to the square root of 11 times 11 times 11. And since it's a square root, I need 2 of the same thing to take one out. So I get 11 square root 11. And this answer cannot be taken down any further because there's nothing that I can break 11 down into to take any of that out of the square root. The only answer that's going to be acceptable here is exactly this one, 11 square root of 11. Let me go ahead and show you just a couple more of these to make sure that you do have a clear understanding of this. Let's suppose, for example, you get an answer like 36 raised to the 5 halves power. Again, not an acceptable result. And there are several ways with which you can do this. Again, I'm going to keep up with the radical, and I'll show you the couple of different ways to look at this because everybody does their math just a little bit differently. If I stick with what I've done before, again, what the number I have here, the radical is going to be the square root. So this is going to be the square root of 36 to the 5th, which is the square root of 36 times 36 times 36 times 36. Oh, I didn't leave myself enough room here. Times 36, 5 of them. And remember, I need 2 of each to take 1 out. So here comes out 136. Here's another 36 that gets to come out. And then I have what's left in here, which is the square root of 36. If you break down 36 into 6 times 6, or just know that that's the square root, what you wind up getting here is 36 times 36 times 6, which is going to give you 7,776. Now, again, as I said, that's one way to look at this. Let me show you what the other way to look at this is. When we do this, it absolutely makes no difference if I write this as the square root of 36 to the 5th, or if I write this as the square root of 36 raised to the 5th power. They are one and the same. Both of these is still going to give me the same thing, because here, if you put this back in terms of its fractional part, you're going to have 36 to the 1/2 raised to the 5th power, and then what do we do with those exponents when it's a power? We multiply them. So that's still going to give you 36 to the 5/2. My point being in this, when I look at this, this may be an easier way in this case to see it. Sometimes it is, sometimes it isn't. Here it absolutely is, because you can go ahead and take the square root of 36 first. That's going to give you simply 6 to the 5th. Square root of 36 is 6, and 6 to the 5th is still going to give you 7,776. So no matter how you go about this, you're going to wind up getting the same thing. Let me go ahead and do one more here, and let's use a different number on that radical than what we've seen before. For example, let me do 36, and let's do it this time raised to the 5/3 power. Okay, so again, we want to keep up with this radical, which in this case is going to make this a cube root. So this is the cube root of 36 to the 5th. Now, the easiest way, and we don't have a single cube root of 36. So if you try to do this in the second way that I just showed you, you really can't take the cube root of 36, so that's not going to help you. But what we can do is go ahead and expand what we have on the inside here. And 36 to the 5th is going to be 36 times 36 times 36 times 36 times 36. Now, since it's a cube root, I'm going to need 3 of the same thing in order to take 1 out. So I have 3 36s. I'll get a 36 out, and that's going to leave me with the cube root of 36 times 36. Now, if I couldn't go any further with this, I would just simply multiply those under the radical, and put them together as one number. But I can go further than this, because each of those 36s can be broken down into 6 times 6. So I can break the first one down into 6 times 6, the second one into 6 times 6. And remember, how many do we need to take something out? 3 of them with a cube root. So there are 3 of my 6s, which means I get 1 on the outside. This is going to be 36 times 6. And of course, I'm going to be left with that cube root of 6 in there. That can't be broken down into 3 of the same thing. You can break it down into 2 times 3, but that's not enough to take any out. So we're going to be stuck with what we see here, which is 36 times 6, or 216 cubed root of 6. And folks, I do want you to understand that no answer you give me on this other than that one is going to be acceptable. We are in calculus now, and I absolutely expect that this is something that you can do. So when I get this answer, this is what I absolutely expect to see on here. Make sure that you can do these problems. One more thing that we can look at here. Oh, by the way, notice on this my notation. Even on a problem as simple as this, and I'm not saying you have to do all these steps in between, but there may be 1 or 2 steps in between. Notice that, for example, on this second one, every time I move down a line, I put an equal to let you know that I am continuing down the page. And then I actually ran out of room. So instead of just going out to the side and then somebody has to guess whether they should go side to side or down and then over, I actually put an arrow here to show you that my problem is continuing and it's continuing over here. Remember I said on day one that we need to be able to follow your work, and this is one way to do that. Make sure that you're doing your notation the whole time. All right, more example here. And this one, let's look at the limit as h approaches 0 of 5 divided by the square root of 5h plus 4 all plus 2. Now I've actually changed the variable on this, but it's still going to work the same. This says to take this function and everywhere there is an h, we're going to turn it into a 0. So baby steps on this if you need to. I have a 5 on the top, then a line. Then I have the square root of 5. Now I'm going to put the h in of 0 plus 4. And let me close that there. And then I have this plus 2. Now, of course, you're going to need to clean this thing up. Anything times 0 is 0. So we get 5 divided by the square root of 4 plus 2. And so I need to finish that bottom. And the question becomes here, what is the square root of 4? Well, and I know that there's some confusion sometimes because sometimes we take the plus or minus and sometimes we do not. Let me just say this up front. The only time that you need to do the plus or minus when you're taking the square root is if you have taken the square root of both sides of an equation. Otherwise the only result you're going to get is the positive result. So in this case, I'm sorry about that, we're not taking the square root of both sides. So when I do the square root of 4, I simply get 2. And then go ahead and add those bottoms and get 5/4. Remember, only acceptable answer. I don't want a decimal on this. I want the 5/4.